a developer relations engineer at DataStax, and I'm so excited to talk to you and walk with you today as we build a superior movie search experience with vector search. This is about an hour. We have a lot of ground to cover, so I'd love to get into it. But before that, let's add a little bit of humanity, to the mix before we dive into AI, just by sharing where we're joining from. So my teammate Michelle has done a great job of warming up the chat a little bit. Will you drop either an emoji or a name of the city that you're joining from in the chat? There's about 300 people registered, and it's such an honor to be able to present to all of you. At best, let's make this a dialogue and not a monologue. And in keeping it a dialogue, I'd love it if you ask questions as I'm going through our discussion today. This is for you. Right, DataStax's mission is to help make GenAI accessible to the widest possible variety of developers. And so if you have questions, I'm here to first and foremost answer them and then continue with the discussion. All of this will be made available over email, and there's a blog post about it already on the DataStax blog that goes into some detail if you're interested. With that, let's get started. Our title for our stream is Building a Superior Movie Search Experience with Vector Search. Building a superior. That's a big statement, right? Superior. What makes it superior? We'll spend a little bit of time talking about that. And then we'll also spend quite a bit of time talking about vector search. And then finally, in sort of our third act, we'll bring them all together. I'm just looking at the chat. I see there's someone here from Ghana. Welcome, Bernard. Michelle from Orange County. Nicholas from Belgium. WL from Switzerland. Absolutely great to have all of you here. Okay, so let's talk about superior movie search. Well, to understand what makes movie search superior, we have to establish a status quo. And superior by definition is better than status quo. So what is the status quo? Well, let's explore a little bit by going and browsing the internet. So let's take a look at some websites. Let's start with IMDb, the world's most popular movie database, right? And if we come to IMDb and it's Saturday night and I want to watch a movie, but I usually don't know the name of the movie I want to watch. And so instead, what I'll do is I will type something that describes the movie. I'm interested in watching a movies, let's say, with a strong female lead, and I'll hit enter. And what I get here are movies titled strong female lead, not movies with a strong female lead. Similar, like movies with superheroes in New York, right? This is how I want to watch movies like this sometimes. And what I get is New York at the movies, Formula E in New York. So this is the status quo, right? The status quo is keyword search, is search that checks the words I'm typing, but doesn't really care about the semantic meaning of it. Again, if this feels relatable, please leave some feedback in the chat, because I would prefer to feel like I'm talking to human beings as opposed to bots. Okay, so this is how let's look at another example of status quo by checking out Netflix. I like Netflix. I love Netflix, actually. I watch, this is maybe not safe for work. Let's scroll a bit. I watch a lot of Netflix. And sometimes, same thing, I want to search for movies with a strong female lead, right? And what do I get? In Netflix's case, it's actually even worse. I just get nothing. Your search for movies with a strong female lead did not have any matches. Try different keywords. This is a problem, keywords. Status quo is keyword search. I think we'll have the same superheroes in New York, yeah. So it just doesn't, that's the status quo. And this is really important because as engineers, I'm assuming many of you are engineers. If you're not engineers, please say so. I'd be very interested to find out what the demographic is. But if you're an engineer, we ideally take pride in creating software that is pleasant for users to use. Absolutely. We oftentimes work for companies and we need to optimize revenue and profit and A/B testing and all of this, but ultimately the end is happy users equals happy customers equals customer retention. And instead of having 1,000 customers who get angry and leave, you have 1,000 happy customers, right? So UX really matters. And unfortunately with keyword search, the UX suffers. This is why the title of this live stream is Superior Movie Search, because with vector search on DataStax technology like Astra and Langflow, which we'll get into, we can create that. We can create a search experience where it's show me movies about superheroes or movies that feature a strong female lead, and you actually get what you want with an emphasis on the criteria you choose. Meaning, if it's a romantic comedy in Europe, you actually get movies that are in Europe, not just about Europe, not where Europe is a keyword. Okay, so that's that's what makes this experience superior. All right, let's talk about vector search and how it establishes that. Vectors are lists of numbers, okay? If I ask you to think of an example of a list of numbers, some would call it a vector, what would you think of? I think the most common type of vector is a two-dimensional vector, meaning a list of two numbers. So think of it as an array in programming. You have an array with two numbers, 1, 2. That's a two-dimensional vector. A vector is a list of numbers that each number represents magnitude, that is how much, and direction, that is which way are we going, meaning to the right would be a positive number, to the left would be a negative number along some axis. It could even be up and down along a y-axis. And in any case, without going too far into the details, a vector is nothing more than a list of numbers in n dimensions. A two-dimensional vector is a list of two numbers, and the most common two-dimensional vector in the world is the coordinate system. Latitude and longitude is a two-dimensional vector system. Okay, if we think about three-dimensional vectors, we have width, height, and depth. Any 3D model exists with a three-dimensional vector because it's just a list of three numbers that convey width, height, depth, and also not just the direction, so width or height or depth, but how far in that direction, right? That's what a vector is, magnitude and direction. Why is this important? Well, there exist specialized machine learning models called embeddings models. They take natural language, words in English like dog and cat and food and pizza, and embed them. Literally, that's why they're called embedding models. They embed them in space. Similarly to this cup here being embedded in space. This cup is, in fact, you could say this cup on camera is embedded, if it's towards the top left, at 0, 0 in terms of left top vectors. In any case, an embedding model will take natural language and embed it in what is called high dimensional space. This is space with more than 2, more than 3, thousands of dimensions. I cannot visualize that for you because we see the world in three-dimensional space. Some would argue that time is the fourth dimension. We just don't have like 1,000 dimensions that I can show you. But that's what they do. They take natural language, words, and embed them in high-dimensional space. And when they do this, words that convey meaning are closer together than words that have different meanings. So for example, assuming this is a block of space, and assuming the term cat and dog would be over here. Cat would be here, dog would be here, right? What about the word for camera? It would be like over here, just different, far away. And then based on these vectors, you can literally just compare numeric distance. So you can compare, for example, if I ask you to compare 8 and 2 with 40, you would say that 8 is closer to 40, but it's not as close as like 37, you know? So that's what we do. So we take text, names or descriptions of movies. We turn them into lists of numbers, vectors, and then we compare. So when a user types romantic comedies in Europe, we compare the distance of that question with the distance to movies that have that in their description. So we vectorize the description of movies, turn them into a list of numbers, and then we vectorize the user's query and just check the distance. How close is what the user wants to all of this stuff in our database? So that's vectors. And that's what vector search is. It's really just computing the distance between lists of numbers. Similar to how we just know, if we know basic math, that 80 is closer to 100 than 2, right? One thing though, is you need a place to store your vectors. And that is usually a vector store or a vector database, depending on how you call it. At DataStax, we make one. In fact, I'm a little bit biased, but I'd say we make the best one for multiple reasons. It's backed by Apache Cassandra, that's one of them, so it can scale pretty significantly, and it is never down. It's very robust and very secure, and I could go on and on. But we have a vector database, and its primary role is to store those vectors and then search through those vectors given a user's query. We look at all of that in our demo shortly. I see a question in the chat. How many parameters you will need to define a vector in n dimension? I don't know what this question means. Maybe ask again, because parameters are they're machine learning sort of knobs, they're weights, right? So how many weights will you need to define a vector? I don't understand that. And I guess the safest answer is it depends on the model. One example is, I don't know, the number of The number of parameters and dimensions are different. I can tell you that machine learning models optimize for a specific number of dimensions based on their training. But in terms of parameters, I don't think this is publicly advertised by most of the proprietary models. Batuhan, sorry if that's not how you pronounce your name. Batuhan, do you offer vector databases? Indeed, we offer one vector database, and that's all you need. You need one vector database. It's called Astra. We'll look at that together. Okay, so hopefully by now we have an understanding of what superior movie search we're going for, and what a vector search is, and what embeddings are. Okay, right. The size and the direction. No, Levent, to come back to your question, a vector is a list of numbers that conveys, magnitude and direction. That's it. That's what's captured by the numbers. And you might ask the question, how does the word cat have a magnitude and a direction? Indeed, it does in high dimensional space. So assuming 1,000 dimensions, you could say go this far at this speed and you'll arrive at cat, basically. Okay, so we've understood what makes movie search superior. We've understood vector search. Let's make this really practical and build this, okay? So to do that, we're going to use Astra. Let's take a little bit of a tour on Astra. I will share my screen and we'll get into it. So for those of you who don't have a DataStax account, this is Astra. It's a vector database, and actually we do more in DataStax now, but Astra has the possibility to go to databases and to create a database. So we've actually created a database ahead of time called Superior Movie Search, as you can see right here. And we'll click on Superior Movie Search. And now it's completely empty. So we can load some data or we can do other things. Let's go to the Data Explorer. I'm going to create a collection. For those of you who are familiar with relational databases, a collection is like a table. It's just a logical way to group your records or your data. So I'll create a collection. I'll call it movies. You can see it's a vector-enabled collection. We just talked about vectors. This is important. How do you generate your embeddings? This is a great question. And there's many different ways we can go about this. With Astra, you can actually generate embeddings on the fly. We're not going to do that. We're going to bring our own embeddings. But we can integrate with an existing embedding provider like OpenAI. So I'm going to come here and integrate this with OpenAI. I can do that by going to Settings, Integrations, and OpenAI. And what I can do is I can add my API key to another database, which is the one we just made, which is called Superior Movie Search. Now that I've connected my database to OpenAI, I can go to it and create a collection that uses OpenAI embeddings. So I'll call this movies once again, using OpenAI. And the embeddings model is text embedding 3 large. And as you can see, it has a predetermined number of dimensions, which is 3072. This looks good to me. We'll use dot product similarity. These are small details that you'll have to dial in for your business case. For us, these are the ones I'm going with. I could go with cosine. They're just similarity metrics. And if you hover on the eye, you can understand what they're about. Typically, it's just a function that determines how close is close enough. So we'll create the collection. And while the collection creates, we can start now thinking about our data. There are many, many, many public data sets available on the internet. IMDb offers its own data that you can download. It's a massive, massive archive. It's like orders of multiple gigabytes. And frankly, we don't have the time to sit and watch a upload as much as I wish we did. And so what we're going to do instead is use a prefabricated list. So we did get a huge JSON list of movies. And we're going to take this list and upload it into our collection. And by doing this, you'll also understand how to get data into your Astra collections yourself, okay? So I'm going to share my screen. There may be some infinity mirroring. You may see me infinite, but we'll see. I'll share my entire screen this time. And so what we're going to do is we have a little script. By the way, this is you in the chat. Say hi. I'm keeping the chat monitored. Okay, so we have Astra. Our collection is ready, and it's time to load some data. We have some data here. If we open up our project, here's where the data is. So we have this script, we have this big JSON file called movies.json. I wonder if I can format it. Cool. So these are just a bunch of movies with IDs, titles, and poster paths. That's all, okay? And we're going to load this huge list of movies into our Astra database. So if we come to loadmovies.py, we just wrote a small Python script to do this. Again, you can write this in JavaScript, you can write this in Ruby, you can write this in Rust, you can write this in whatever you want. We just chose Python because we feel like it, okay? So what's actually happening here? Well, we're reading the file movies.json, And then we get AstraPy. This is the Astra Python client from DataStax. There's also a TypeScript client if you're into that. What we do then is we initialize the client, we connect the database, and we get the collection movies. Now these environment variables are going to be different because I just created the database. Let's go and get them. And again, these will be redacted after the stream. Please do not steal them. This is my DataStax account, okay? So what we're going to do is come here, back to my dashboard, go to my database, which is Superior Movie Search. And so I've got the API endpoint here. I'm just going to copy that and load it into an environment variable in .env right there. These are all my secrets. Again, they'll be redacted. Be a decent person. And then we'll generate an application token, and we'll copy that and also paste it into our .env. And this time they don't let you see it, but when I paste it here, you're going to see it anyway. Cool. So we've loaded up our application token and our API endpoint. Finally, we're going to be using the MovieDB to get metadata about this movie. The MovieDB is a really great project that has a really great API that's very accessible. And so we're going to get the movie's details. We're going to get its category, and we're going to load its data into AstraDB. Okay, so the content is just the description and the page's content, and we're going to be using unstructured for that. So once all of this is ingested, we'll be ready to go. I'm going to now run the script. So I'll cd into scripts, and I will Python 311 load movies.py. Whoa. Is it just Python load movies.py? The demo effect. I've got to install it. So we'll pip install our requirements.txt, and now we can run it. Interesting. I think it wants Python 3.12. This is the thing with Python usually, is it doesn't really know which version. So we will do load movies.py. I might have to go venv on this. Let's see, pip 3.12 install. Interesting. Yeah, okay, let's just do a venv. A venv, for those of you who aren't familiar with Python, is a virtual environment that encapsulates a lot of your application's dependencies. So we'll try this. We'll create a venv, and we will source the venv path to venv. Okay, /activate. Bin activate, right? Okay, cool. So now we're in the venv, and now we can pip install requirements.txt. There, it should be working, but it's not. It's okay. You know, for situations like this, we have stuff ready. Okay, well, that's not going to work. In some cases it does, but we have a backup. No worries. We have movies already inside our database. So we can, I mean, not this one, we just created the collection, but we have a backup database called rag++, where we actually presented this. So if we come to the Data Explorer, let's assume the ingestion went totally fine. And now if we come to movies, we have stuff inside our Astra database. Again, if there's time at the end of the live stream, we'll go back and fix that. But in any case, this is what it would look like. And this is literally the after effects of running that script. So we've got content, and the content is the name of the movie and some of the page content, literally the content from the web page on IMDb. Okay, so we've got a bunch of this, and we can already start checking how this works. And we can do that by typing here. Let's search for movies about superheroes. Apply. And so now it's going to convert my string of text into an embedding using OpenAI, as we saw. And it's showing me that the most similar thing has about a 75% confidence rate, and that the third most similar thing is close to the first most. So we have some good results. Let's see what the results are. So I hit that, and you can see here that the content is The Avengers, Captain America, Justice League. This is so cool. Let's try another query. Movies with a strong female lead. Wonder Woman, The 355, Kate, Lady Bird, perfect. Movie, what was the other one I said? Romantic comedies in Europe. Oops. We should really fix that. If you hit enter, it opens a new line instead of submits the form. That's a little bit of a mea culpa on our side. Okay, so romantic comedies in Europe, Notting Hill, Below Her Mouth, through my window, a romantic comedy centered on Dexter. And okay, so these look like they're in Europe. This looks great. So it's already working, but we're missing something really important. We're missing a way to actually use this in an application and create that superior experience we talked about. But from a data engineering perspective, this is the way. Hey, thank you, by the way, for everyone in the chat suggesting VN was the better way to do this and stuff. I would love to. Now I'm nerd sniped. You know, I'd love to spend honestly the rest of the stream debugging that. I'm not going to do it, but yes, we'll come back to it. I'll come back to it in the middle of the stream, or I will solve it after the stream. In any case, we have our database full of movies. They're being vectorized on the fly. How you might be wondering how the text is being vectorized. Let me show you that again. I'm going to share my screen. And by the way, if anyone has motion sickness, I apologize. We'll be bouncing in and out of screen share a lot here. Okay, so let's share my entire screen and come back to this. How is it actually that the web page content is becoming vectors? Well, the unstructured URL loader is going to look at the movie page for the specific ID from our JSON file, like this. And then look what's going to happen. It's going to get the title, it's going to get the category, and then doc.page content is literally the entire text content of the page. We pass this content, once we clean it, of course, we pass it to a field called $vectorize when we inject it into Astra. And Astra is smart enough to look at that field, $vectorize, and automatically on the fly, using our OpenAI integration, convert it into a vector embedding. Absolutely cool. So we don't have to talk to OpenAI directly at all. This all just happens, right? Using our OpenAI API key. That's very, very important. Okay. So we have that working. How can we use it? Well, let me show you something called Langflow. Langflow is a perfect complement to Astra for many reasons. Mainly, Langflow makes it very approachable to take data and build real-time AI applications. If you've ever heard of RAG, that stands for Retrieval Augmented Generation. It's where you get data, usually out of a vector store, and give it as context to an LLM or large language model to give you a nice, meaningful, human-readable, semantically sensible answer. Okay, that's what RAG is. We're going to do RAG to create this movie search experience. Bogdan, you're asking if this will be available on demand. Indeed, it will. Michelle will send out an email with a follow-up tomorrow. Okay, so let's look at building a RAG application with all of this data. And to do that, we're going to use Langflow. Let me share my screen. Again, let's go to Langflow. So this is Langflow. It's actually running locally. You can self-host Langflow. It's fully open source. And this is just on, look at my address bar, 127.0.0.1.7865, right? So you can host it locally and own your whole pipeline. We also have a hosted cloud version of Langflow at DataStax. If you want, you can use, but you don't have to. There is no lock-in here, okay? So let's create a new project. Let's call it, this is blank, that didn't ask me for a name. You know what? We'll call it Untitled. So what do we want to do? Well, we want to get data out of Astra and give it to an LLM, a large language model, and help it give us answers. So how do we do that? Well, for starters, we actually need an input, some type of chat input to give a prompt, right? And this is where we'll type something like romantic comedies in Europe. Then from that, we need to construct a prompt. Actually, we don't need to, we need to, before we do a prompt, we need to actually search the database with this. So if we go to vector stores and get Astra, okay, and look at this, it's so cool. We're actually building a GenAI flow, but using just visual stuff. It's so cool. Okay, so with Astra, what are we doing? Our collection's called movies. We have an application token and an API endpoint. These are going to have to be different. So I'm going to use the one from my database that we just made. So let's go back to .env, copy these and just use them here. Application token, what is that? I just copied the endpoint. The endpoint doesn't need to be credentialed because it's an HTTP URL. The application token does. So you can create a reusable secret, but since it's not reusable, we're only using one Astra component, so this should be fine. I'll just paste it in. Normally you can add a variable if you reuse things. Okay? So our search input is the chat input. And so we're going to be searching Astra for that. Then we need an embedding model. So to do that, we'll go here and get OpenAI's. Since we're using OpenAI and Astra anyway, OpenAI embeddings right here. We're using text embedding 3 large, and we'll connect this just like that. That's it. So now it's going to give us search results, and we'll need to do something with those results. What can we do? with those results? Well, if we have a helper for parsing data, we actually get a bunch of data. So we'll just take this, and this will parse the data into text. And let's just do a chat output for now and see what we get. So if we connect all this up together and try, we can go to a playground and search. This is just the same vector search we were doing in Astra, but now with Langflow, right? So we'll say movies about superheroes. And so we're going to query Astra, and it's going to return a bunch of Astra records here. So this is the text field from Astra, literally. As you can see, this is not ChatGPT. This is nothing. This is just the text field from Astra. So let's go back. When an unexpected enemy emerges. So this is the synopsis that we got from unstructured, from reading the text content of the website. Cool, but it's not natural language. How cool would it be if we put an LLM in front of this? Because I can't be like, which of these is good? It's just going to return me movies. It can't actually talk to me. You see that? It's just searching the database. What is 3 plus, I don't know, whatever. And most LLMs can do this basic math, but it can only return movies because this is just database search. Now, if we do RAG and put an LLM in front of this, then it gets interesting, and we build something closer to a superior experience. So let's go models and choose OpenAI. And again, check this out. There's Ollama. Ollama is a way to run a model locally, so you can also do that. But we'll talk to OpenAI. Before we give the movies to OpenAI, let's construct a little prompt. Okay? And here's what we're going to do. We're going to create a prompt. And prompts are cool because they can create variables. So we'll say, given this list, actually, the user asked for movies that are described by, and we'll say query. These are the movies, and we'll say movies. Return them a list that addresses their query. I don't know, something like that. So we have two variables, right? We have the query from the user, that's this one, and we have the movies that will return from Astra. Okay, and now we give this prompt as input to OpenAI. We're going to be using GPT-4o Mini, the latest, cheapest model, and this should just go. And so let's attach this now to a chat output and go back to the playground. I must say, I really like Langflow. It's such a great tool. Okay, so playground. Let's restart this, and we'll just ask, like, what is 4 plus 8? Actually, no. Let's tell me about good historical movies. I wonder if Gladiator would come up. You'll notice it's a little bit longer because it's not only doing the database search, but it's doing database search and generation. So here's a good list of good historical. It's talking to me. That's so cool. And it's formatted with Markdown. And it knows the director, and so it's nicely structuring. What is 8 plus 3? And I could also, like, this is not just movie search anymore. This is some of the emulated reasoning capabilities that we get with LLMs, right? So what is 8 plus 3? Which equals 11. Here are movies about what is 8 plus 3. What? And so this is so cool, right? Tremendous. So we have this, but we've built just another chatbot. And honestly, I don't know how useful this is. I think it's very cool that it can tie, like, random things to give me movies. For example, I had to, can I zoom in? Yeah, I have to do a live stream today with 300 people. It's fun, also nerve-wracking. And it's going to take this, do similarity search for movie descriptions, and then give me the perfect movie to watch just based on random data about my day. And it tells you why. Becoming. Join former First Lady Michelle Obama that explores her life, about how it's relatable because it's nerve-wracking, unbelievable, right? I do feel like I'm in an escape room right now because none of you are engaging with me in the chat. Oh, I just didn't scroll down. Anyway, I'm joking. So no, anyway, this is already somewhat superior, but it's just another chatbot. It's just another chatbot. Okay, there's questions. Let me take some questions and then let's put a UI in front of this. Batuhan is asking, is it possible to make multiple columns on cosine similarity? One column is, for example, content of the movie. The other is the aesthetic, and we make search in multiple cosine similarity. That's a great question. You could do that by taking and vectorizing each one of those, what you would call columns, as a single vector. It's the same thing, because then it's going to do similarity search for each of those criteria, right? And it's going to search for numerical closeness. So this is a case where you could put those columns, let's call them labels, you could put all those labels into one vector and one column, and you will achieve the same outcome that you want. Nicholas is asking, can we use this in a similar interface as ChatGPT instead of a chatbot? See, now, Nicholas, now we're talking. This is what we're going to dedicate our next half to, is making this better than a chatbot. Nicholas, you said it so well. I believe that the chatbot experience is cheap and uninspired. I will say that. It's maybe controversial, but we have so many chatbots, and I think we can do better, right? And this is where I want to explore our statement, our thesis from the beginning, which is we want to create valuable things for users. And if users are customers, then customers, because really by creating truly great UX, everybody wins. We create great products that maybe convert to revenue, but also people are just happier. I think of travel booking websites where you go to book flights, and they are not pleasant user experience by and large. And when we experience something truly good, we notice, right? I think chatbots are similar. So let's see what we can do that's better than a chatbot for superior movie search. In fact, I built a UI that doesn't work, that's maybe better than a chatbot. Let's take a look at this as I share my screen. Share my entire screen again. Thank you for engaging in the chat, by the way. Y'all are really nice people. If you'll be willing, could you drop a thumbs up emoji in the chat just to continue to be nice? Okay, so let's now put a nice UI on this. I actually built one. I'm going to npm run dev, and I can show you. This is using TypeScript and Next.js. You can use whatever you want. But if we go to localhost 3000, check this out. We call it movies plus plus at DataStax, and it's a cool little search field. It's not a chatbot, it's just a search field, and I can type in things like movies with a strong female lead, or I can just click the suggestion, and guess what? Nothing happens because it doesn't have the functionality yet. And together we're going to build that, and we're going to use Astra and Langflow and all of this. Okay, so how can we get started? Well, I'm going to close this first. We don't need this anymore. I'm going to open the code base here. This is our Next.js application, and it has just UI and nothing more. So if we look at this, if we go to page.tsx, this is what we have. We have main, we have a header, and the header is a flex box, so it's side by side, and we have a logo, and we have a search form. And I can change this, and it will change. Look, logo, hello, and if I save, you see, I'm not cheating you. This is like actually the page, okay? The search form, in turn, has a text input, right? And I can also mess with this. I could change this to, I don't know, and it will change. Whoa, I don't know where that went. Can you come back? There we go. So, and suggestions. And suggestions are these little things here, okay? Suggestions, finally, have a suggestion where they use a hook called use movie search. That gives you a function search. And so when you click on a suggestion, ideally you search, but nothing happens. We can see why nothing happens is because search does literally nothing, but we can say alert hi, and now it does something. Great. So there's absolutely no AI here. Let's add AI here in our remaining time together. To start with, we're going to create a file, and we're going to be using the Vercel AI SDK. Full disclosure, I used to work at Vercel. I love Vercel. I think they're one of the greatest companies in the entire world. And so we're going to use it because they just create great stuff. So we're going to do export const AI. If you can see my screen, please let me know. If you can't, then I will bump the font size. Okay. Oh, thanks for leaving thumbs up. You guys are so great. Okay. So, and girls and non-binary folks. So let's go export const AI, and what we're going to do is we're going to call a function called create AI. We're importing this from AI RC. That's from Vercel's AI SDK. We need initial AI state, which is an empty array. AI state and UI state are just a bunch of conversations. They're just like messages, lists of messages. Okay, and finally actions. And actions can be whatever we want. In this case, let's start with the suggestion. Let's take the search function and make it do something. So we'll get the conversation so far, and append it. So we'll do set conversation is use UI state. Okay, and again, the conversation is just this UI state. So we just get a function called set conversation, and then we get the result of, we call a function called continue conversation, and we'll define, none of this exists, we're going to define it. Okay, let's make this full screen. We'll get continue conversation from use actions. Again, this is not defined because our actions are empty. We'll define an action. Okay, continue conversation. Okay, so now what do we pass continue conversation? Let's just pass it a piece of text, which is our prompt. Okay, in fact, let's lift these up here. So we have the result. What we can do is we can set conversation to old conversation. Let's just say this is any, and we'll spread the old conversation and the result. So we expect the result to be a message. Okay, so we'll save this. This looks good. However, continue conversation is undefined. So let's go define it as an action. So what do we want? Well, continue conversation. It's an async function that gets a prompt. Look, GitHub Copilot AI already knows this. So what do we want to do? Well, we want to get a result, and we'll say it's the result of awaiting stream UI, another function from the Vercel AI SDK. Okay, what does stream UI take? It needs a model. In this case, we're going to use OpenAI's model. We've been using OpenAI this whole time. And we're going to import OpenAI from AI SDK / OpenAI. So we'll just import OpenAI from AI SDK / OpenAI. And we'll call it with the model that we want. In this case, let's say GPT-4o. Then we need to pass in some messages. But what are our messages? We need some way to get our historical messages. Well, we can say history is get mutable AI state. Okay, and what we can do here is just pass in history.get. I think that's a promise, so we'll await. Wait, perfect. We'll await history.get, and we'll pass in the prompt from the user. Okay? And then what we can do is return, and we'll say role is AI, content is the results value, just like that. Instead, we'll say display is the results value. Cool, sorted. This is great. Does it work though? Let's see. So what we're gonna do is just try it, I guess. I love it. So a couple of things. One, we forgot to declare that our AI context needs to execute only in a server environment, and use UI state must be wrapped inside an AI provider. So let's go to our layout. This is like the root of our entire page. You can see our HTML document begins here, and we'll wrap this thing in AI like that. Where does AI come from? Again, in create AI, we wrote this export const AI. Okay. So now let's try. Hello. Is anything going to happen? No, nothing's going to happen. Let's try that again. What's going on? Do we have errors? We do not have errors. I think, oh, I know why. Silly me. Finally, we're not actually using the conversation. It's just an empty array. So we'll say result is use UI state. Aha. There we go. There, perfect. It's totally working. So let's try this again. Hello. And hello, how can I assist you today? Who are you? Yeah, kind of cool. I mean, we built another chatbot, but we're getting there. We still have some time. Also, this kind of looks pretty nasty. I'll pause here, look at questions, and come back. Okay, cool. There's lots of thumbs up and no questions. I love it. Let's continue sharing my screen. Hey, I just need to take a moment. Y'all are so cool. Thank you for sticking. No, Levin, don't go. In any case, Vijay, I will raise the font size. Let me share my screen again. So this is where it gets really good. Levin, you're missing out, man. So let's go back to our application, this one. And okay, so it looks good. We're getting back text. So you know what? Let's format this text a little bit. Let's go to our AI component, our continue conversation. And if we get back text, what we can do is, it's a function that returns some stuff. So what does text get? It gets content, it gets done. So we can say if done, history dot update. And we can do this. We could pass in the old let's just await history dot get. It's an async function. Okay, so we can pass in the history and the result, right? That's kind of what we're doing here. Its role is assistant, not AI. Okay, great. This is also assistant here. And we return the text. So we're just like persisting some conversation history. It's content. Great. But we could do better. Since it's a function that returns something and we're in the web, one golden rule of the web is a function that returns UI is called a component in React or Angular or Svelte or whatever you want. So we can actually return UI here. In fact, we can wrap this in Markdown, which is our Markdown component. And immediately things get a lot richer. So let's try again. Hello. Who are you? Okay, so there's some spacing. Show me a list of facts. And I'm just trying to see, look at that. So there's bold text and our Markdown is working. This is so great. But again, I said earlier, we're not here to build a chatbot. We're here to build a rich movie search experience. Okay, so let's do this again. Let's say, show me romantic comedies in Europe. Totally working. And the cool thing about this is it just knows to include the name of the movie and the location. Vienna, Austria, Surrey, England, Provence, France, Rome, Italy. So cool. But again, it's a chatbot. How can we make it UI? Well, since we're getting this text, we can do a bunch of stuff that is very, very interesting here. For example, instead of text, we could just return a list of movies. And so what if we do our vector search here, right? What if we, instead of talking to OpenAI, do our vector search and just get a list of movies? So let's try this. So let's say in the event of text, do this, but let's create a tool. Tools, and this is tool. So the LLM, the large language model, is going to call these functions when it feels right, based on the function's metadata. So we'll say show movies. Okay, and a function can get some parameters. So parameters uses Zod, which is a schema validation library, to describe its parameters. We have an object, the genre. Okay, or even better, let's do criteria. How about that? It's a string. Then we have a description, which is, this is how you tell the LLM when to call this function. Now, LLMs can call tools similar to how I as a human being can call tools. For example, if you ask me to multiply 18 prime numbers, I'll go like, I don't know how to do that. And I will go reach for a tool, a calculator, and I will call it and I will use it. LLMs can do this. If you say, hey, these tools are available. So if you can't do something, use the tool and return its value. So that's what we're going to do here. So use this tool when the user asks to be shown movies. And finally, we need a generate function that gets the criteria and generates an answer. Okay, so how might we query Astra with this? Well, DataStax has an API, so we'll import data API client from DataStax AstraDB TS, and we'll instantiate the client and query it. So here, we'll say const client is new data API client process.env AstraDB application token. Const db is client.db process.env AstraDB API endpoint. These are environment variables. Collection is movies. And now we can get data. So what we can do is we can say const data is await collection.find, and we'll pass in vectorize is the criteria, incredible, dot to array. This should be all the data we want, and we can just, let's return just the data as a string. This is probably going to look nasty, but let's just validate that it's working. So show me romantic comedies in Europe. Let's hit enter. It's going to maybe query Astra. It's going to fail. Oh my goodness. Okay, so we got like a bunch of stuff in JSON from Astra. You can see ID and all of this. It's kind of nice. Let's now see if we can return like UI from this. So we have this component movies.tsx, and movies, it can take JSON, right? An array of title, poster path, and underscore ID, and return some UI. What UI? Well, links and a beautiful little movie picture. So do we have that? Do we have title? Let's check. Okay, so we have title. This is great. Do we have poster path? Okay, so this is compatible. So let's just, I'm actually making this up as I go now. So let's return movies, where movies is data. Oh no, what's the problem? Is missing. I think this is just wrong. Save. Let's try again. Show me romantic comedies in Europe. Oh my goodness, this totally works. Incredible. It gave me a lot. So I don't quite like this. Let's just ask for a limit of, that is so cool though, right? This is generative UI. This is what we're talking about. No chatbots. Okay, let's do better and do a limit. Let's say limit 4. I don't want too many. So we'll go here and limit is 4. Okay. Let's do something different. Let's do show me movies about computers. I don't like this lag. Okay, cool, that works. Nice. Let's reload, start from scratch, and show me movies about the future of AI. This lag, I hit enter, it takes forever. I really don't like that. Also, Her with Joaquin Phoenix isn't in it. Anyway, we can do even better because remember, I hope you're still with me. I haven't looked at the chat in a while. Let me take a quick look at the chat to make sure you're still with me because this is honestly the juicy part, right? You don't want to miss this. Just a second, I'm taking a look at the chat. Nicholas is leaving. All of you are leaving just as it gets good. Thanks for coming. You'll watch the video after. Okay, so we have some generative UI. However, we started this by talking about superior and UX. We want this to be like great user experience. This lag, when you hit enter and have to wait a few seconds, it's not really the best UX. Let's fix this by adding some polish. Cower the princess. Yes, you can get the recording later. So let me share my screen and we'll land this plane. So I'll share my screen, my entire screen, and we'll go to our application here. I want to be able to create a spinner or something because like show me your favorite movies. I don't know if this is going to work, but there. So that latency, wow. Who knew that OpenAI would have favorite movies, and who knew that Predator would be one of them? Isn't that concerning? Anyway, so let's fix this loading situation. Well, for those of you who know JavaScript, there's a way to do this using generator functions. So we just literally add the keyword function star. And this says this function is a generator. And a generator can return multiple times by using the keyword yield. And you can yield, do some work, yield, do some work, yield, do some work. And then finally, when you're ready, then you can return. So let's look at how we might do this. We can start by yielding. We have a spinner, I think, right? Somewhere, spinner, integration spinner. Let's yield this, and we'll actually put this in a nice little div. We'll use tailwind, flex, items, center, a gap 4, gap 2. And we'll yield a spinner, and we'll say, say something like searching Astra. So we'll yield there when it's searching Astra. Then we'll yield again. We'll just say like rendering movies. I don't know. So now we know, right, where the work is being done. So let's try this again. Joaquin Phoenix greatest hits. I think this is not going to trigger the tool because I'm not asking to see a movie. Oh, no, it is. Great. So now we actually also have that really great spinner. Check it out. So this is our finished thing, right? Like romantic comedies in Europe. Beautiful. Look at that. Searching Astra. It's going to search Astra. Rendering movies. Ooh, stunning. And now you can even, because the text piece is still built in, right? This is still there. You could do something like describe the plot of one day. And that's because text exists. This shouldn't do a movie search, but it should actually generate some text. Perfect. Look at this. We have like multimodal movie search. And you could, in the future, when you have enough context about yourself in a vector database, am I going to like this? Now it has no idea of knowing, of course. But see, it's like, could you give me your preferences? But if it knew that, I am interested in huge monsters. Show me movies that I would like. There we go. So you can, oh wow, that's actually really nice. For those of you who haven't seen Godzilla -1, let me know in the chat. Is it good? I kind of want to see it. I heard good things about it. Anyway, we went from nothing, 0, to getting data from somewhere, loading it into Astra. Astra vectorizes this data on the fly with one field. And like that alone, we're ready. We also did the search in Astra itself. Remember that text field? We validated it worked. We went to Langflow. We built a API application as well. And then we said, okay, cool, this is great for a chatbot. How do we do generative UI? And indeed we did, using the Vercel AI SDK. Absolutely incredible. This is, I can say confidently, truly a superior movie search when compared to the existing status quo of keyword matching. If you agree, leave a thumbs up in the chat. We have a few minutes. I'd love to take your questions. If not, I'm happy to also leave it here. So I'll allow maybe, I don't know, like 30 to 60 seconds for questions. And I'm really happy to have a dialogue discussion in these last few minutes with you, because ultimately this is for you, right? I could do this myself. I could do this to a wall if I wanted to, but no, this is for you, the developer community. So if you have any questions, I'm happy to take them. The input data, yeah, Antonia Docal, for sure. Let me show you the input data. In fact, if there's no questions, I'm more than happy to, I'm more than happy to like debug that Python script and figure out why it failed. So this is this here is the, where is it? Let me open the project. It was here. This was the load movies script. This was the input data. Let's format this a bit. So it's just it's about 5,000 rows of movies by ID, by title, by poster path. And then how we actually ingest it into Astra is we use the unstructured URL loader from the LangChain community's loaders of documents. And what we're going to do is load up the moviedb/movie/ID, the ID we get from here. The MovieDB has a really great API. And then we get the page's content, just the text content. We clean it up. There's this function called scrub that just removes a bunch of stuff, like login buttons and so on. And then we insert the entire page's text content into Astra in a field called $vectorize. And $vectorize is automatically converted into a vector embedding on the fly on Astra. So that's the whole process. And again, if it fails, you just like retry and so on. Now, if there's no further questions in the chat, there are. I was going to inspect why that failed. Can we do a recommendation for multiple databases? So not just the description, maybe user preferences. Can we do a recommendation from, again, this is the second time the question has come up about multiple something. Previously, there was a question about multiple columns and doing similarity search across many columns. Now the question from Bogdan is a recommendation for multiple databases. I mean, in theory, you can, and you can stitch them together in your application logic. But if your data is modeled correctly, I'm not fully convinced that you have to. Because again, vector similarity search searches for the similarity between numbers, and these numbers are derived from strings. So follow the logic here. You could put a lot of the same or similar strings, even across databases, concatenate them into one string, store them in one column in one database, and still all your features are captured in this vector. Then you search for similarity for that vector, and it will point you to the full record or another database or so on and so forth. So I think there's a really great book, a really, really great book called Designing Data-Intensive Applications by O'Reilly. This book, I have no financial relationship to the book. I am an O'Reilly author, but this book is required reading for anything GenAI. Really, because it's garbage in, garbage out. And I think there's a lot to be said for modeling your data Bogdan. I'm not sure you should chain together multiple databases, and there are probably better ways to do that. All right, next question from Syed Jaffrey. So where or how can Langflow help for building superior production-ready experiences? Such a great question. Let's walk through that a little bit as well, given that we have some time. I'd love to share my screen again and show you here how we can do that with Langflow. So I already showed you how Langflow can help you build great RAG experiences, right? Let's make that a little bit more practical. So if we come here, let's go to Langflow. And so we have this RAG application. I could say something like respond, let's go to OpenAI, and I could tweak the system prompt with respond only in valid JSON. And let's turn on JSON mode. And now let's try this, show me romantic comedies in Europe. So it's going to do RAG. It's going to retrieve movies from our database, use an LLM to generate language, but not English this time. Actually, JSON, look at this. This is perfectly valid JSON. Romantic comedies in Europe, title, description, title, description, title. That's cool, but I don't want this key. So then you can even introduce like schema adherence by just tweaking the system prompt. With schema, movies, name, string, description, string, and we'll add square brackets to indicate an array. You just write like some basic schema. We'll try it again. And so you can rapidly iterate like this and really create a RAG flow that is completely perfect, reproducibly and deterministically. And so it's going to think a little bit, and we're going to get, there we go. So it's exactly as I described: movies, name, and description. So I can make an API. So cool. So we're getting back JSON, but I can now go click on this API button, and I get, look at this, I get a full HTTP API. And of course, you can deploy this in Docker in any host you want, AWS or Azure. We also have a hosted version of this on DataStax. You can literally just query this deterministic. So I'll come here, I'll go to my terminal, and I'll just like paste this curl request right here. And I will pipe it to JQ. And we will get back a response from Langflow. So it's like this diagram becomes an API that just, there we go, it just works. Look, this is the response: movies, talk to me, etc., etc. And it's JSON, right? And so you can go very quickly from nothing to creating like a full-on RAG-ready, production-ready API with Langflow. So I hope that's super helpful. I hope that answered your question as well, Syed. We have 2 minutes left. There's another question. Is there a way to filter first and then search? For example, filter on a field column, then search the vectorized field. At this point in time, the data API and DataStax does not support that. It doesn't support filter first and then do vector search. It also doesn't support do vector search and then filter. This is something we're working on, and it's honestly community feedback like this that helps us prioritize and make sure we serve developers. So thank you for that, Theodore. Bogdan asked for the name of the book. Thank you, Abe, for pasting the link. And I believe with about a minute and a half to go, that's the last question. Again, we have a minute and 15 seconds. So if you have more questions, again, this is for you. So I would love to answer that. Any recommendations about how to start with Vercel or TypeScript? Yes, use GenAI, Perplexity.ai or GPT-4 or ChatGPT can help you. I think Perplexity.ai is a great one because it does RAG, like it searches the documentation and teaches you according to your questions. So Abe, that'd be my recommendation. How can I deploy this on DataStax directly from Langflow Cloud version? Great question. Log in to DataStax, use Langflow, and it should be already deployed for you. Now the API piece is, if it's not already available in DataStax Cloud, it will be shortly, I believe within less than a month. All right, 30 seconds left. Hey, thank you so much. This was so much fun. I can't wait to do this again with you. I appreciate you, developer community. Let's do this again, okay? Thank you so much.